That I'm audible and my screen is visible. Just a text message will be good enough for me. Any confirmation, please? May increase the volume. Okay, how do I do that? I have a microphone in front of me. Okay, fine. I'll talk a bit louder. Okay, so in the last class, some of you are asking about why don't we actually have an hands-on practice of Aspen. So I just designed a small problem in this session. Okay, we'll be uh, simulating a refrigeration system. Okay, just VCRS cycle, vapor compression refrigeration system, to get started with. Okay, so before that, what I'll do is I'll just summarize whatever professor thought, and we'll have few couple of problems. Okay, multiple choice questions as usual. And so by the time we come to end of this multiple choice questions, I want every one of you to be ready with your Aspen. Okay, if you have active license with you. Okay, in case if you are yeah, before just starting, how many of you don't have active Aspen? Can you just put a chat, right? Can you put a text in the chat box so that I'll know? If you don't have, we'll have to think for some alternative. You total 8 students. So how many of you have Aspen with you now? You are able to use it? Okay, I'll do one thing. I'll just put a poll for this. Can you just answer on the poll? Sort of 8 students, right? Only 8 of you have joined. 2 are from my own tab. So 8 of you have joined, and out of 8, 7. Okay. So 6 of you have, right? That's great. Fine. Then we'll just do a simple exercise problem, but I'll just summarize, okay, whatever professor thought. So professor basically started with property analysis tool, and he described how to we calculate properties of pure component or binary or ternary, different things, right? Then he discussed about Henry components, where do we use Henry's law, what are applicable areas and all. Then he discussed about thermodynamic properties, transport properties, how are they different, is briefly summarized, right? Then he discussed about different ways of calculating this equilibrium things or thermodynamic calculations, different equation of states, interactions of real and ideal cases, just explanation. It's all basic fundamental thermodynamics, right? So okay, then he compared two different equations. So he said, in some of the cases where, for example, in case of butane and toluene, it is observed that the ideal thing almost predicts the actual system. However, in case of water phenol, when we consider binary system, it is observed that the actual is labeled over here. However, what we predicted from ideal gas is this, and what we predicted from Wilson is this. So in such a system, it can be observed that neither of the equations, nor the ideal, neither the ideal nor the Wilson have actually predicted what experimentally is observed, right? So as I keep, over the lectures, as I keep on telling the same thing, right? A model is just a prediction of how the system behaves, so it can always be off. So that's what professor showed this. Then he discussed about activity coefficient based methods. Where do we use it? In which situation do we use? I think, if I remember correctly, he briefly explained about reactivity equation as well. Then different kinds of equation of states available for vapor phase calculation. He just gave a brief introduction of those. Then yeah, so that's what he told during the course of time. Okay, so next week, we'll have some more discussions regarding this property analysis. That time we'll discuss further on. Okay, so it's all clear, right? Whatever professor thought in the lectures. Okay, so if it is all clear, I want you to answer this question. See, I made very few questions, okay, for today because I want every one of you to actually use Aspen and let me know where you are facing trouble, okay. So I have very few questions for you people today, and we'll do an exercise problem, okay. So just bear with me for a few minutes. Some simple questions, but yes. So this is your question: which among this is following the transfer property? So these questions are made from lectures, okay. So this is a proof that you heard the lectures and tried attempting the assignment questions, okay. So for that reason we made this. Let me switch this off first, and then switch on this. Okay, so which among the following is the transport property? Viscosity, enthalpy, entropy, and phase equilibrium. Okay, thanks for your response. It's just straightforward question, right? When given among whatever given all the thermodynamic properties, right? So the only transport property is viscosity. So I have another question. So which among these is a thermodynamic property? Can you just answer for this? I'll have a poll for this as well. Just give me a second. Okay, launch. So given four options, which do you think is the thermodynamic property? Viscosity, I think you already have the answer for that. Chemical potential, surface tension, density. Okay. See, in the lectures, professor has explained this, okay, clearly. When we talk about thermodynamic properties, we talk about properties of the fluid, okay. So it says density, molecular weight, enthalpy, entropy, gives free energy, okay. So it can be a physical property or chemical property, okay. When you talk about thermodynamic, it's all three, right? It's chemical, mechanical. What is the third one? Any response? Any answer? I just want to brush your basics. When someone says that your system is in thermodynamic equilibrium, what all equilibriums will it be in? Any response? If someone says that the system is in thermodynamic equilibrium, okay. So what all equilibrium does it mean? What kind of equations do we write for that? Yeah, that's great. So yes, so when you say system is in thermodynamic equilibrium, then all your thermal properties, temperature, concentration, okay, which is chemical, and mechanical, which means pressure. So all temperature, pressure, and chemical potential essentially being the same, okay, between two systems, right? So then yes, we have another question. So the user can neither modify nor create property methods in Aspen Plus. Is it true or false? I have a poll for this. Just give me a second. Okay, so the question is we can't create a property method in Aspen. Is it true or false? Okay, before answering the question, all of you have understood, right? What is a property method? If you don't have a clarity on property method, please let me know. I'll explain it. Okay, explaining is not an issue, but please let us know in case if you have difficulty in property method and you need an explanation. I can give it. Okay. Yesterday I'll tell you what happened yesterday. Yesterday I was taking one of the class on MATLAB. It was in-person discussion, okay, it's not virtual. So I was just continuously giving lecture and people were not asking me questions. So I thought it's fine, everybody has understood. Then I gave an assignment problem for them to solve. And I gave us 8 questions and hardly students have solved only 4 after 3 hours. So then I asked, what is your problem? People were having difficulty in writing few codes. Okay, so it's, I took that lecture in person and now I'm taking it in virtual. So please do ask me if you are unable to understand anything or couldn't follow any of the lectures from professors. We'll explain it. It's not an issue. By default, I understand that you have you are very clear with everything, and also if you are unclear, do let us know. Okay, so see, good that some of you have raised your hand regarding explaining things. So please explain. Yeah, that's all. We'll explain it once again. What's a big deal? Let me open a fresh file. Okay, so can you just point out something regarding what you are confused? If you are, if you can specifically tell me if you have some 1 or 2 points, we'll just clear it off directly. Or you want me to explain the property analysis completely? Just add a comment, okay, so that I'll just go ahead with whatever you want to teach. Acha, how many of you have noticed that in the previous lecture, Professor Prabhakar Kumar Saha was present? How many of you have noticed it? Regarding calculating the parameters using the properties and how to modify. Which parameters? See, I actually didn't go through your lectures, okay, so I don't know what is being taught clearly. Okay, it's been really long time that I went through your lectures. So can you be a bit specific regarding which parameter you are talking of? Is it binary interaction parameter? How the property method are changed during different problems? Okay, so you want to know how do we select property method itself? Is that what you mean? Yes, okay. Okay, last week I have explained this. Probably you are okay. I'll just explain. Let me open Mandela and see the differences. I'll explain you from difference itself directly. Okay. Yes. See, I have shown this plot last time, okay? So essentially it gives you the way to how do we select property method. The same thing runs at background of Aspen, okay? So when you go to help in Aspen, there will be a flow sheet. You will be asked, it will ask you continuous questions one after another. It will finally take you to one answer which is actually derived from this flow sheet, okay? So given the input components, if you know the properties, for example, if you take hydrocarbons, there is no interaction between one molecule and another molecule. We'll say it is non-polar. Okay. If let's say for that one of the hydrogen atom is replaced with fluorocarbons. Okay. In that case, you have hydrogen bonding and it becomes polar. So your first basic thing is to distinguish between polar and non-polar. Once you know that it is a non-polar, and if you don't have any pseudo components, or if you have pseudo components, it's a no pseudo components, right? That means we don't have pseudo components. Then you can use these equations, okay, for vapor phase property calculations. Preferably you can use the same for liquid phase calculations also. However, it's not that advised, okay? And if you have some pseudo component with you, then you'll check whether it's high pressure or low pressure, right? So normally, which normally we say that gases behave like ideal gas at low pressure and high temperature, right? So if you are dealing with low pressure fluids, then you can assume ideal gas is very well, ideal gas equation is very well valid in our case. If not, then we'll use something else. Okay, so based on properties of the fluids which we are trying to model, we'll select different equation of states. Okay, so maybe I'll do one thing, I'll share this file with you. Okay, this might be helpful. I can do that. Okay, and yes, you want me to show this property, right? Let's do this once. Okay, see, I have selected air. Okay, so essentially this is just a template which is already available in Aspen. So when I go to methods for air, the default is Peng-Robinson equation of state. Okay, you can use any other thing also. Okay, now if one is interested in calculating properties of air, we'll say, go to analysis, we'll say new analysis. See, here we want to generate a PT. Let us say it's some generic thing. Okay, you can use which flash calculation algorithm you would like to use, and you can also give composition. Let's say we only want to calculate properties of nitrogen, then we'll give variables. Okay, let's say we're calculating it a constant pressure thing, and I want to vary temperature. So from which value to which value, or let's say minus 150 degree centigrade to 100 degree centigrade. Okay, so essentially we are giving our required input data. Okay, what we want to calculate. So what I want to calculate from here, so I want, let's say, enthalpy. Okay, I'll do one thing, I'll say enthalpy. It says enthalpy of mixture. I'll select this. I'll just explain. Okay, I'm just going fast. I'll come back and explain. So essentially we can calculate properties of different components or mixtures, individual fluids from Aspen. Okay, these properties are calculated based on equation of state which you have selected. Okay, for example, the ones which I have shown you here, I just calculated properties for nitrogen. Okay, nitrogen, that too I took Peng-Robinson equation of state. If I change the equation of state, the properties which I have calculated will automatically change. Okay, because everything is based on the property method which you have selected. For example, let's say for example, we'll do one binary mixture. I wanted some specific thing which I don't find. Okay, let us generate PT envelope. Yes, this is what I was looking for. Okay, let us assume this to be 78, this to be 21. Okay, now we are discussing about this. We do is change the method. Yes, see, here you have method, right? So you can select density marching. This is more efficient than the conventional thing. So density marching method is actually a product from our own lab. Okay, so so we know what is running at the back, and it's far better and advanced from the conventional method which Aspen uses. This density matching method is introduced recently, okay, to Aspen. Now it's a contribution from our own lab. So when you just run this, uh, yes. So how many of you understand PV envelope? Do you understand PV curve of a given pure component or a mixture? Any just put a text here if you understand. Say you're able, how a PV curve looks. If you don't know, see, there's nothing wrong in accepting you don't know, that's fine. So essentially, if see, you have three axis system, right? One way you have pressure, one way you have temperature, one way you have volume. So what is equation of state? Given two properties, it calculates your third property. Okay, so essentially in every equation of state that you are using, we'll try to develop this 3D curve. Okay, and projection of this curve on different 2D planes is what we call it as envelopes. Okay, for example, if I say on x-axis I have pressure and y-axis I have temperature, z-axis I have volume. If I want to project this xy axis, I'll get pt envelope. If I want to project this yz axis, I'll get pv envelope. Okay, so pv is the fundamental curve which we learn. However, in future, with respect to any industries, pt is the most common one which is used. Okay, so this essentially gives you fluid properties at various conditions. Okay, okay, I'll do one thing. I'll just make a slide explaining PV curve and PT curve the next class. Okay, so if one is interested in knowing the properties of component, you can just go to analysis and do all this. Or instead, the simple way is to see that you have tabs over here, right? You can just generate any type of things you want. However, be careful that sometimes this Aspen will fail. Okay, maybe let me see if I remember an example. uh, okay, methane type 3 fluid, if I remember correctly, it's ethane or methane. Let me add both. It's been quite a while that I took this example. It's no, not this. I want to generate sure. Okay, I don't remember that example exactly. What happens is, for the given property, Aspen fails to for the given property method, essentially Aspen fails to calculate properties. Okay, it will give error in flash and all. So those kind of cases are also possible with Aspen. So just be careful while selecting your property method. uh, in case if Aspen is failing to predict your properties, you can use different property method. However, there is results obtained from property method will always not be true. Okay, so your results may be way off from what you are estimating. Okay, so let's just keep these things aside. Okay, now I'm just skipping these things. Okay, I want to solve this problem first. Okay, so is this question visible to you all? If you have software in front of you, can you just try solving this problem? This is very simple exercise. Okay, so given you have vapor compression refrigeration system, I'll just show this figure. Okay, this is your figure. Okay, let me just go. I'll just delete this. Okay, so now we are trying to simulate this process. Okay, given vapor compression refrigeration system. Okay, this is a simple thing. Now the TS diagram for this is given over here. So what is happening is, the fluid is just getting compressed from 1 to 2. Okay, the fluid which we are talking is propane. Okay, propane we are compressing from state 1 to state 2 through a compressor, and then cooling it down to 3, then expanding it in a throttle. Okay, last class I explained, right? What is the expansion process in throttling? Can anyone comment? What is constant in the throttling process? It's expanded, and then from 4 to 1 is just getting heated. So this is our process. Now the question is, it says that the condenser outlet is saturated liquid at state 3. So at state 3 it is saturated liquid. From the plot we can identify it. This is saturated liquid line, this is saturated vapor curve. Sorry, not line, it's curve. This is saturated liquid curve, this is saturated vapor curve. So at state 3 it is saturated liquid, and at state 1 it is saturated vapor. So these are two given conditions, and it is also said that the temperature level at which we are operating at state 3 is 50 degrees centigrade, and state 1 is 10 degrees centigrade. So this is 50 degrees and this is 10 degrees saturated vapor. Okay, now we are expected to calculate the compression work given the mass flow rate of propane is 1 kg per second. So this is your question. If is that question clear to you, or shall I just explain it once again? Any comment? Is this question clear? So the basic idea is to find the compressor work given the lower temperature and upper temperature. See, what is a refrigerator? It pumps energy from a low temperature source to a low temperature body to a high temperature body, right? Given the work. So here this is at 10 degrees centigrade and this is at 50 degrees centigrade. We are giving work and it's just shifting the Q or the heat, right? So now we have been asked to calculate work given the flow rate of propane is 1 kg per second and two temperature levels are given to us. Okay. Okay, I'll repeat it once again. Okay. So we have a vapor compression refrigeration system. What does a refrigerator do? It pumps energy from a low temperature body to a high temperature body. So we have low temperature at 10 degrees and a high temperature body at 50 degrees. And we are supplying work to take energy from a low temperature body and supply it to a body at 50 degrees centigrade. Okay. So in the means, what is happening is we have a secondary fluid propane which is having an interaction between these two bodies. Okay, the lower body is called evaporator and the top above body is called condenser. Right? Now the given conditions that the flow rate of propane in the system is 1 kg per second and at state 3 it is said that it is saturated liquid. Okay, and at state 1 it is said that it is saturated vapor. And the temperature levels given, it's the temperature of 3 is 50 degrees and that of 1 is 10 degrees centigrade. Our idea is to calculate work of compression. Okay, so now is it clear? See, whoever not commenting, okay, I'm assuming that you are following everything, and this question you are supposed to solve and tell me the answer. I'll be just waiting here. Okay, given this information, is there anything else which is missing for you to solve? Can you just tell me if you need any other information for solving this question? Any response? Okay, pressure. Any other thing which you need? Okay, can you please repeat? Thanks for your response. Okay. See, in any refrigeration system, what happens is uh, you have two bodies at two different temperature levels. In this case, we have one at 10 degrees and one at 50 degrees. What we learned in our basic thermodynamics is that no, we need to supply work for transferring energy from a low temperature body to a high temperature body, right? So we are supplying work to compressor for transferring heat from a low temperature body to a high temperature body. Okay, so in this case the low temperature body is called evaporator and the high temperature body is called condenser. So this transferring of energy is not done directly. Okay, we have a propane which is circulating between these two temperature levels and in between we have work input. Now our idea is to find out work that we need to give to this system to make it operate. In that process, the given data is that the circulating flow rate of propane is 1 kg per second and the state 3 which you see in figure 1 is represented in figure 2. Okay, the state 3 is saturated liquid and the state 1, okay, which you see the suction side of the compressor, or technically call it as suction side of the compressor. You can, to simplify it, you can just call it inlet of compressor. Compressor inlet is saturated vapor. Okay, it's a pure component system. We are just running with propane. Given this information, we are expected to calculate compression work. Okay, see, it says 50 degrees at state 3 and 10 degrees at state 1. Given flow rate of propane is 1 kg per second. So this is the question. Now, if the question is clear or unclear is the first question which I want to ask. Is this clear? Yes, that's great. Okay, so what all you need? One says which property method to use. That's a good question. That's actually the thing which I want from you guys. Thanks for your responses. See, what additional things we need? We need operating pressures. Yes, that's a good question. We need property method. Yes, without property method we can't calculate it. What additional thing you have asked? Compressor efficiency. Yes, you need compressor efficiency. So I would say we need. I'm giving you these things. Where is this? Let me just exit. Then I can get a fresh thing. Okay, so given use Peng-Robinson equation of state and use compressor efficiency as 72%. Now will you be able to solve, or do you need any other information? I gave you property method as Peng-Robinson equation of state and compressor efficiency as 72%. Do we need any other information? Any response? Any other information do you need, or will you be able to solve it? So see, if you are not messaging, I'm by default I'm understanding that you should be able to solve it, and yes, you are solving it on the way. Shall I zoom that? Okay, pressure. Do we need pressure for this operating pressures, or can we calculate the operating pressures? Yes, we are using the valve, correct? It's valve, right? Expansion throttle. It's valve. See, for this problem, we actually don't require pressures. Okay, so indirectly it is given to us here. If you see in the question, it says location 1 is saturated vapor at 10 degrees and location 3 is saturated liquid at 50 degrees. So, given it's a pure component, it is said that it is saturated liquid at some temperature. Can't we calculate pressure? If we can calculate, how do we calculate it? See, these questions you are supposed to answer. Okay, from Steam table. Thanks for your response, but the component which we are using is propane, not the steam. That's a good idea. For steam, we actually directly take it from Steam table and then calculate it. Thanks for your response, but the component which we are interested is in propane, not the steam. Okay. That's a wonderful answer from Anton's equation. That's great. So in Aspen, do we have Anton's equation? So when you do it mathematically with hand, pen, paper, then you can just directly use Anton's equation and calculate it. Okay. So how do we do the same in Aspen? Correct. Yes, thanks for your response, Mr. Aaron. So you are supposed to use pure component property analysis to find out the pressure for the given saturated temperature. Okay. Uh, People who have knowledge on this, how to find it, just continue with the question. Okay. Others just think over it. Okay. Towards the end of the class, I know depending on your status, I'll explain the answer. Okay. So essentially what you're supposed to do is your first step is to calculate saturation pressure of propane at 10 degrees and 50 degrees. Okay. Once you know the pressure, you will be able to set up the flow sheet. So you have two tasks here. First to find the saturation properties and then to simulate the cycle. You have two different tasks, okay? So unless you do the first one, you won't be able to set up the simulation file. So first do a property analysis to find out saturation pressure at the given temperature for propane, and then do the flow sheeting, okay? And if you are getting stuck somewhere, do post it on the chat box, okay? And do give me an update, where are you and what are you doing. I'll be waiting here for your queries, okay? You guys understood, right, how to proceed to solve this question, or you still have confusion with the approach? Just text something that yes, you are confident on how to solve this, or no, you are not confident on how to do this. Just put something. Else I'll have to call out one after another. How to calculate pressure on Aspen? Okay, thanks for the question. Let me see if others are okay. Mr. Arun, you are okay with this problem? You'll be able to solve? I'll go one after another. I think that's the best thing that I can do. Mr. Arun? Or Abhishek? Mr. Akshay? I think Akshay is the one who texted, right? Yeah, okay, sorry. Got it. Okay. Mr. Harshit? Any response? Action in one company. Okay. Okay, carry on, Arun. Mr. Prasanna Kumar? Prince, how about you? You are able to solve? Or you know the procedure? Can't figure out the pressure. Okay. Okay. We'll do this. No worries. So first idea is to add propane to this. Okay. Let me delete other components. I think I have a file for this. Let me just open it. Yes. So the first step is to select the component, right? Then these are previous ones. Let me delete this. Okay, so the first step is to give the component which we are interested in, right? Then the next step is to give property method. Go to method, give Wenger Robinson. Alright. Now the third step is to find the saturation pressure. You know, I'll do one thing. Instead of giving a pure component, can I do it in mixture itself? Okay, I'll show you first this one. We'll say pure, the property which we want to measure. See, when you just drop things, you will see that you can measure hundreds of things over here. Not measure, sorry, estimate, calculate. See, it says free energy, enthalpy, it says fugacity coefficient, it says entropy. You'll be able to solve multiple things. It says internal energy. So can we do this? Can we find a dew point or boiling point from this approach? Any response? Okay, thanks for response, Mr. Prashant Kumar. We'll do in a generalized approach, okay? Why to do with a single thing? Just go to analysis. It's a generic, okay? Now we have only propane. So what is the fixed thing? We are fixing temperature, right? Now we'll just vary a dummy thing, okay? We are varying pressure. It's just a dummy thing, right? We'll say that's all. And here we want to tabulate bubble point and dew point, okay? See, what is bubble point for a pure component? It's just bubble point and dew point will be the same, right? So see, oh, what did I give? I gave pressure on it. Okay, so essentially what I'm calculating is at 10 bar. Now I see that it has a bubble. It has a boiling point of 26.8. Oh, what I'll do is I'll change the pressure. Okay, instead of giving just as 10, I'll say from 10 degrees, right? Let me give this 5. Okay, so I'll say let me give increment of 0.01, and then let me see. This is one approach, okay, the difficult approach in fact. So now we want the saturation pressure at 10 degrees, right? See, even till 5 bar we didn't get this, so we'll just shift this. This is a crude way of doing, okay? I am explaining you so that you will be able to do for different things. This is for propane we can just directly do for from a pure component analysis, but once you have a mixture it will be hard to do. So now we have two things, right? So one we want at 10 degrees. Right, let us go down. So at 10 degrees we have the saturation pressure of 6.37 bar, right? See, we are saying its bubble point, it says 10.04. Let us assume that it's 10, it's 6.34. Now let us see for 50 degrees centigrade as well. Just take a note of it, okay? If you are just writing it, it's the suction pressure is 6.37, and on the discharge side you have 50 degrees, right? Yes, see, for 50 degrees it's 17.21 bar, right? So could you follow how to do that, or do you need one more explanation for this? Anyone, could you follow what I did? Okay, see, what I did is I selected propane, then went to analysis, right? So in the input I just gave 1, it's the mole fraction. Then this is just dummy, okay? You can fix anything. We'll say just dummy. Then I varied pressure, okay? I varied pressure from 5 bar to 20 bar, okay? Then I tabulated what is its dew point and bubble point. For a pure component, dew point and bubble point are the same, right? It's the boiling point. Now I just ran this analysis. Then I understood that now I got a relation between pressure and temperature. If you see, it will be just a straight line. On x-axis I have this. See, essentially it calculated so it calculated saturation temperature at different pressures. So instead of going from x to y, now we are trying to find x from y, okay? So now we want to know what is its saturation pressure at 10 degrees. Okay, so see, at 10 degrees we can see that the saturation pressure is 3.7 approximately. Okay, need not be accurate. I'll tell you how do we accurately calculate. Okay, just give me some time. And at 50 degrees centigrade we can see that it's 17.21. So is this approach now understood? Could you follow? Yes, that's great. Thanks for your response. So now since you know the pressures, operating pressures, can you set up the flow sheet? I'll show you the problem. Can you set up this flow sheet and see what is the compressor work? In case if you are getting stuck somewhere, do text me, okay? I'll be waiting here for your response. What is this, Mr. Akshay? I didn't understand your point. Main parameter for variable selections. Can you please expand it? Yeah, Abhishek. Just put a message. What's your problem? You're raising your hand, right? So, Mr. Abhishek, I'm assuming that you're able to follow and are able to solve everything, okay? Because I don't see any response from you till now. I don't, yeah. Can I ask something about exam after the course? I have zero knowledge regarding exam. Professor Prabhakar Kumar Saha will be taking care of the examination. You can ask, but I won't. I am not in a position to respond. How to add a variable component? I didn't get you, Mr. Akshay. What is this variable component? Yeah, I can show you the problem. I was reading your chat, so that's why I did this. Do one thing, all of you take a screenshot of this question, okay? so that you have this question with you. I'm just changing the tabs, right? Can you please upload solution of previous assignment problem or video solutions if possible? Lots of thoughts to notice where the mistake. Okay, assignment problems. Okay, I'll have to discuss with professor regarding that for giving you the solutions. Okay. Fine, I'll update you in this regard. So all of you took a screenshot of this, right? This one and the question as well. What happened to the strength? It's suddenly going down. I see that first class there were 250 students, second class around 80, third class there were 20 to 25, I remember correctly, and now only 8 or 7 in fact. Is there any reason? Yeah, I'll show the second screen. Just want to know why is there a sudden drop in the strength? Last semester when I handled this course, I think towards the last I had about 18 students, but now I just start of the course itself I have about 8 students today. Interesting to see. Just want to know the reason out of curiosity as well. Oh, you're not getting notifications. How come? See, actually I registered for this course to check whether I'm getting notifications or not. So I get I get on every Tuesday regarding this live lecture. Please check the mail through which you have registered in NPTEL. Because I get a mail every Tuesday since I have registered for this course. For knowing this only, I have registered for this course. Okay, whether students are getting last class, you are not getting. Maybe some technical issue in that case, because I received a mail from NPTEL today saying a reminder for the live session. I don't know what could be the reason. So, do you think that's the reason why students haven't joined today? Okay, please continue with your simulation and tell me the final answer. Okay, now check the availability. Okay. So, the better idea is to send a WhatsApp notification, is it? Okay. I check my email once in 5 minutes. You are that used to of using the mail. Now you are telling they don't see every day. Depends on the area where you go. So can you just update me your status? Where are you? Could you set up the flow sheet? See, I'll do one thing. You take this problem as a homework, okay? Solve it and come back next week. We'll start with this problem directly. What do you say? If reference material for this course, it's there in the course website, right? Professor gave two references. Just see in NPTEL because I remember reading two references for this course. Yes, both have soft copies. I I can't tell you the website links now, but yes, you can download it from internet. Both have soft copies. Ah, yes, boss. Officially, you can't download it. I can't tell more than this. Or you wait till the end of this lecture. I'll tell you where you can download. Okay, see, do one thing. Take this problem as homework and come back the next week. So everyone has this problem with you, right? You have, no, you took a screenshot of it, right? I'm assuming you took a screenshot of it. So take a screenshot of it and no, do this problem. It's a simple problem, okay? In the week, and we'll discuss this. We'll start our lecture with this problem. Let me first start the recording.